So, I have way too much styrofoam. Sounds relatable? Because we all do. Like, check this out, I have huge bricks of it and bags of styrofoam peanuts as well. But how about we turn this into something useful? So with some chemistry magic, these huge space-filling foam pieces can be turned into a cool chemical, which, despite being toxic, flammable, and carcinogenic, is still one of the most produced and useful chemicals of all time. That's right, it's styrene. By the end of this video, I'll try to turn styrofoam into this liquid. Warning, this experiment involves hazardous and carcinogenic chemicals, should only be done with experienced individuals with safety precautions. The chemicals here are toxic and carcinogenic, and ventilation is mandatory. This is only for educational purposes, and don't attempt this at home. So the first step is transforming these styrofoam blocks into something we can work with. Styrofoam is actually just 5% polystyrene and 95% air. You can see how much space it takes up normally, and it is definitely not feasible to do any sort of depolymerization with this. Thus, the best way to shrink it is to dissolve it in a solvent. I can grab a beaker and pour in a good amount of acetone, which is great at dissolving the styrofoam. I can start pushing in a block of it. As you can see here, it gets dissolved completely with no difficulty, and the huge bricks can all be shrunk down to just 5% of its original size, or less. What we have now in the beaker is just condensed polystyrene fibers. There's a lot of fizzing and also a melting sensation, which makes it super satisfying, and I had also a lot of fun putting in these pieces. Now when I've exhausted the acetone's capacity of dissolving the styrofoam, no more could fit in, and now it's just a huge slimy brick. You can see how it's gooey and stringy, like mozzarella cheese, but seriously don't eat it. With the acetone still in this slime, it's a huge fire hazard, so be careful while handling this. It's crazy how those huge blocks of styrofoam you saw earlier that took up so much space could easily be compressed into this small blob. In order to drive off all of this acetone, I'm gonna have to dry it. The best way to do this is to put it in a pan or a flat surface like this, and let it sit for a couple of days until it becomes hard and dry. I also mass-produced a bunch more batches of this goop off camera and put it at like 100 times speed to save you some time. Here you can see how I technically had 3 pans, but here I only showed 2. I had a good amount of this styrofoam goop. So now, it's just a waiting game. When I came back, they were pretty much all dry, and so now I can move on to the next step, which is to actually depolymerize the polystyrene. That's right, basically no reaction has taken place yet. This is when we break it into a bunch of smaller constituents, mainly the monomer styrene, but also some other junk. However, I wanted to do this step in a round bottom flask, but the opening was too small for many of the pieces to fit in. Look at this huge plate of just polystyrene. So I had to painstakingly chop these extremely hard pieces into pieces that could actually fit through the neck. When this was all finished, I transferred them into a 1-liter round bottom flask. This was definitely the most annoying part of the procedure, but it was still essential. I spent a lot of time just doing this step. After a few minutes of shoving these pieces in, I basically filled the entire thing up and it was looking all good. But here's where the chemistry goes wrong. I somehow had a good idea to use a camping stove for this rather than an ordinary hot plate because for some reason I thought a hot plate wouldn't get hot enough for this depolymerization. Well, surprise surprise, it was completely sufficient. I didn't know that at the time though. Now using the flame, I made a mistake, which was placing it too close to the round bottom flask. Here you can see how at first nothing much happens, but as I gradually continue heating it up, some nice decomposition products start forming, which you definitely do not want to breathe in because it will give you cancer. And speaking of that, look what happens. Yep, the borosilicate 1-liter round bottom flask that I bought for $30 cracked because of the concentrated heat stress. The fumes started pouring everywhere, so I had to evacuate and vent the place. When it cooled down, I took a look at the aftermath and you can see how it cracked entirely. Now I thought the styro chips were going to be a pain to remove, but luckily the glass didn't shatter and broke up into these polite huge chunks. So after painfully taking apart the round bottom flask, you can see this satisfying smooth cluster. Now again, I had to chop it up into small pieces because they all unfortunately fused together, but this time, I decided to do it properly in a metal paint can like the way I made benzene in a previous video. So after fitting it into this small can, I decided to do it in 2 batches because it couldn't all fit in. Now again, making a distillation setup and fitting the flame under it, it actually seemed like it was working well. You can see some dense white smoke coming over, but for the most unreasonable reason ever, the paint can started leaking at the lid. I was sure it was nice and tight and this never happened before, but I guess it's just the way of the chemistry gods to prove that, nuh-uh, Success doesn't come that easily, so yep, again, even though being extremely frustrated, I followed the rules and put everything back into a round bottom flask, despite my PTSD begging me not to lose another 30 bucks. I pushed on and this time I used a hot plate. After setting up for distillation, I turned the heat on max and the dense white vapors started coming over again. Sadly, I forgot to tell you this, but this wasn't actually styrene, but just smaller fragments of the polystyrene polymer, as its boiling point is very low. This time, my round bottom flask didn't crack, and the fumes started pouring into the condenser. This is commonly observed, but within the first few minutes of the distillation, no liquid starts collecting. Again, please do this in a fume hood or outside if you don't want cancer. After a period of time, the distillate starts dripping over as this cloudy yellowish liquid. It slowly collects over time, and I was pretty happy that it was actually working. It was a little impure though, as you could see, because it should normally be clear and not yellow. I wanted to stop it when I felt it was done, but again, as I said, the forces of chemistry came back to fight me again. This time, I really don't know how this could happen, but my hot plate suddenly broke. Like either the heating element or the connections just quit. It stopped heating completely, and there was nothing I could do. I tried taking this $600 used hot plate apart and couldn't find any issues, so if you could give me some tips, it would be greatly appreciated. Unfortunately, I had to end it with this amount of distillate, and even though I had a broken hot plate, I still wanted to purify it. I decided as a last-ditch effort to use the camping stove for the redistillation, because I didn't want to keep you guys waiting for the video, but it really didn't work out and didn't have excellent temperature control. If it cracked, it also would have been a disaster as the entire setup would go up in flames. I'm really not sure how this many things could go wrong for just a single experiment, and I'm sorry for not being able to fully purify this styrene. I will do it in a future video though, so stay tuned. I have seen from some other people like Nile Red that you could use a magnesium oxide catalyst in the depolymerization part, but I'm not really sure of the theory behind it, and it was also quite hard to get, so I didn't try it. Anyways, dry distillations like this, like the time when I made benzene, are almost always extremely messy and they produce too many side products and vapors that are really annoying to work with, as well as the cleanup. Like just take a look at this sticky tar left in the round bottom flask. You can't clean it out with a bunch of acetone rinses though. So if you are going to try this, make sure you do it in a fume hood. Things often don't go the way planned in life, and this is especially true when it comes to chemistry. And sometimes you gotta learn to accept that, because maybe your turn hasn't come yet. It will come for me though. Please consider a sub. Also, one last word before I go. As you guys might have guessed, chemistry is expensive, and if you would like to help me out in making this channel sustainable and free for everyone in the future to come, please consider joining my Patreon, where you get shoutouts early as well as special content normal viewers don't normally get to see. Just $3 would be of great help for a high school student like me. And with that, I'll see you in the next one.